Hello viewers. In today's session, we are going to discuss two important results related to matrices, right? And here we are going to discuss these two important results related to Hermitian matrix and skew Hermitian matrix, right? So before proving these two important results, let us quickly see the definition of Hermitian matrix and skew Hermitian matrix. So let us start. So now let us first consider the definition of Hermitian matrix. So for the sake of simplicity, let us consider a square matrix A of order 3, that is this is a 3 cross 3 matrix, right? Now here we have written all the 9 entries, 2 1 plus I, 3 minus I, 1 minus I, 3 1 plus 2 I, 3 plus I, 1 minus 2 I, and 1. And here I is the complex number, which is also known as iota, right? And I square is equal to minus 1. So here we can see that this is the diagonal, right? So this is the diagonal of this square matrix of order 3, and these entries are complex numbers, right? So a Hermitian matrix is defined as a square matrix whose complex conjugate, that is the transpose of the complex conjugate, is equal to the matrix itself, right? So let us first find out the complex conjugate of this matrix A. So we can denote the complex conjugate by A bar, and here we can now replace all the i's by negative I to get the complex conjugate, right? So we have here 2, then we have 1 minus iota, then we have 3 plus iota, then we have 1 plus iota, and here we have 3. Here we have 1 minus 2 iota, and then 3 minus iota, and 1 plus 2I, and here we have 1. So here we can see that the principal diagonal, it contains all the real numbers, and the rest of the entries are complex numbers, right? So the complex conjugate of this matrix A is given by this matrix, right? Now let us find out the transpose of this matrix. So we have A bar, and here we write a dash or prime. Then here we have 2. To get the transpose of this matrix, we have to interchange the rows by columns. So we have 2 1 minus I, then we have 3 plus I, then we have 1 plus I, and here we have 3, then we have 1 minus 2I, and then we have 3 minus I, 1 plus 2I, and here we have 1. So to get the transpose of this matrix, we have interchanged the rows by columns, and now we can see that this matrix is equal to this one, that is the uh, transpose of the complex conjugate of matrix A is equal to the matrix itself, right? So a Hermitian matrix is defined as if we have a matrix A whose order is, say, n, that is it is n cross n matrix, and it is denoted by Aij n cross n, then this matrix A is said to be Hermitian matrix if the transpose of the complex conjugate of this matrix A is equal to the matrix itself, right? So now let us take the definition of skew Hermitian matrix. So now again, for the sake of simplicity, let us consider a 3 cross 3 matrix A. and whose entries are 4i minus 3i minus 3 minus I minus 4 plus I, 3 minus I minus 5 plus 2i, and 4 plus I and 5 plus 2i and 0. And here we can see that the diagonal elements are either the complex numbers, that is 4i or minus I, and 0, right? So let us find out the complex conjugate of this matrix A. So we have A bar, and now again to get the complex conjugate of this matrix A, let us replace I by negative I in all these entries, right? So we have here minus 4i, then we have here minus 3 plus I, then we have minus 4 minus I, then we have 3 plus I, and then here we have also plus I, then here we have minus 5 minus 2I, and here we have 4 minus I and 5 minus 2I, and here we have 0, right? Okay, now let us take the transpose of this matrix, that is A bar, right? So we have A bar dash, and to get the transpose of this matrix, let us interchange the rows by columns. So we have here minus 4i, then we have minus 3 plus I, then we have minus 4 minus I, then we have 3 plus I, then we have I, and we have minus 5 minus 2I, and then we have 4 minus I, 5 minus 2I, and here we have 0, right? Okay, so now let us multiply this matrix by minus 1, right? So taking the multiplication of both sides by a negative 1. So multiplying both sides by a negative 1. So now here when we multiply this matrix by a negative 1, then each element is multiplied with negative 1. So here we have 4i, that is plus 4i, then here we have minus 3 minus I, then here we have minus 4 plus I, and then here we have plus 3 minus I, and then we have minus I, and here we have minus 5 plus 2I, and then here we have 4 plus I, and here we have 5 plus 2I, and here we have 0, and we can see that this matrix is equal to this one. Here we have 4i minus 3 minus I minus 4 plus I, then we have 3 minus I minus 5 plus 2I, 4 plus I, 5 plus 2I, and 0. So this is equal to our matrix A. So now we are in a position to define the skew Hermitian matrix. So a matrix A, which is a square matrix of order n, is said to be a skew Hermitian matrix if the matrix A is equal to the negative of the transpose of the complex conjugate of matrix A, right? So if we have A is equal to negative of the transpose of the complex conjugate of matrix A, then the matrix A is said to be a skew Hermitian matrix, right? And in case of Hermitian matrix, if the matrix A is a square matrix of order n, and if the matrix A is equal to the transpose of the complex conjugate of matrix A, then the matrix A is said to be a Hermitian matrix, right? So now let us prove these two results. So the first result says that the diagonal elements of a Hermitian matrix are necessarily real, right? So if we see this matrix A, which we have just proved that it is a Hermitian matrix, then this is these are the elements of the diagonal, right? And here we can see that 2 3 1 are real numbers. They are not complex numbers or imaginary numbers. So the diagonal elements of a Hermitian matrix are necessarily real. So we must have the diagonal elements of a Hermitian matrix as a real number. So the diagonal elements cannot be imaginary numbers or complex numbers. And in the second case, the diagonal elements of a skew Hermitian matrix are either purely imaginary or zero. So here we have taken this example, and here we can see that these are the elements of the diagonal, right? And here we can see that we have 4i, a minus I, and a 0. So the diagonal element of a skew Hermitian matrix are either purely imaginary. So 4i and minus I are purely imaginary numbers. These two numbers do not contain the real part, right? Or the diagonal elements may be a 0, right? So here we have this element as a 0. So the diagonal elements of a skew Hermitian matrix are either purely imaginary or 0, right? So let us prove these two results one by one. So now, in the first case, the definition of the Hermitian matrix is A is equal to the transpose of the complex conjugate of matrix A. So let us denote the elements of matrix A by Aij, where I goes from 1 to n, and j also goes from 1 to n, because we are taking the matrix A as a square matrix of order n, right? So here we have A, I, J, and the elements of the transpose of the complex conjugate of matrix A are denoted by AJI, and here we have the conjugate, right? So we have the conjugate of AJI is equal to AIJ. Now for the diagonal elements, I must be equal to J, right? So substituting I is equal to J in this equation, we have AII is equal to I, and here we have the complex conjugate, right? So now let us take AII as a complex number, that is P plus Q, where P and Q are real numbers. So we are taking the diagonal element, that is AII, that is I comma ith element, as P plus IQ, where P and Q are they belong to the set of real numbers. So let us take this equation as equation number 2. Now let us take the complex conjugate of this element. So we have AII bar is equal to P plus IQ bar, right? So this bar indicates that we have to take the complex conjugate. So replacing this I by a negative I, we have P minus IQ. So let us substitute the value of AII as P plus IQ in this equation, and A bar II is equal to P minus IQ in this equation. So we have P plus IQ is equal to P minus IQ. right? So now taking these two elements to the left hand side, we have p plus iq minus p plus iq is equal to 0. So this p and this p get cancelled, and here we have 2iq is equal to 0. So iq plus iq is 2iq, and 2iq is equal to 0 implies q is equal to 0, and q is the imaginary part of this element, that is aii, where p is the real part, right? So taking q is equal to 0 in this element, we have aii is equal to p plus I times 0. So this is equal to p plus 0, that is equal to p. So we arrived at this conclusion that the diagonal element, because the diagonal element is denoted by aii, right? Because for diagonal elements I is equal to j, so aii is equal to p, and p is the real part of the complex number p plus iq, right? So we have proved that the diagonal element of a Hermitian matrix are necessarily real, because q is equal to 0. So in all cases, the imaginary part of this complex number is going to be 0, and only we retain only the real part, that is p. So aii is equal to p. So now let us consider the second case. So here the definition of skew Hermitian matrix is given by A is equal to negative of the transpose of the complex conjugate of matrix A. So if we denote this matrix A, which is a square matrix of order n, so the elements of matrix A are given by Aij, and the elements of A bar are given by a bar ji, then due to this definition we must have aij is equal to negative. Here we have the negative sign, negative of a bar ji, and now for diagonal elements I should be equal to j, and obviously I and j runs from 1 to n, right? So now for diagonal elements we have to take both I and j equal. So taking I is equal to j in this equation, we have ai is equal to a negative of a bar of I, right? Okay, now aii denotes the element of the diagonal. So let us take aii as a complex number p plus iq, where p and q belongs to the set of real numbers, and remember p is the real part and q is the imaginary part. So we have the complex conjugate of aii as a bar I, and here we have p plus iq bar, and this is equal to p minus iq, right? So here again replacing I by a negative I. So let us substitute the values of aii as p plus iq and a bar I as p minus iq in this equation. So we have here a p plus iq, and then we have negative of p minus iq. So let us solve this equation. So we have here a minus p plus iq, right? So taking these quantities to the left hand side, we have p plus iq plus p minus iq is equal to 0, right? So now these two terms get cancelled, and we have p plus p is equal to 2p, 2p is equal to 0, so p is 0 by 2, that is equal to 0. So we have arrived at this conclusion that the real part of this complex number, that is p plus iq, is equal to 0. So now taking p is equal to 0 in this element, we have ai is equal to 0 plus iq, because p is 0. So we have aii is equal to iq, right? And this suggests that the elements of the diagonal are purely imaginary, right? Because here the this term doesn't contain p, right? P is the real part. So this number, that is iq, is purely imaginary, right? And here if we take q is equal to 0, then in that special case aii is equal to 0, that is I times 0 is equal to 0. So in this case aii is equal to 0. So in the case of skew Hermitian matrix, the elements of the diagonal are either purely imaginary or equal to 0. So in case of q is equal to 0, aii is equal to 0, right? So viewers, this is how we can prove these two important results related to Hermitian and skew Hermitian matrices.